Hey everyone, so in this video we're going to go over the exponent rules that you learned from the last assignment. So you were tasked with writing expressions in your TI Inspire and then filling out the table of rules at the end of the assignment. So if you have not completed that assignment, first complete the exponent rules assignment before watching this video and completing the practice assignment. Alright, so briefly going over these rules, we have the 0 rule, which states that x to the 0 power is always equal to 1. So that means anything to the 0 power is always equal to 1. So that could be 24 to the 0 power, this is equal to 1. 1023 to the 0 power, this is equal to 1. Some variable b to the 0 power, this is equal to 1. So anything raised to the 0 power is equal to 1. Now, if you had x to the a times x to the b, how you would write this with just one x is x to the a plus b. So, for example, if we had x squared times x cubed, this would be x to the 2 plus 3, which is 2 plus 3 is 5, so x to the 5th. And this is a rule that we use a lot when we're foiling binomials. For the quotient rule, if we have x to the a over x to the b, how we simplify this is as such, so x to the a minus b. So x to the a over x to the b is equal to x to the a minus b. Another example, so we have x to the 2, so x squared over x cubed. This is x to the 2 minus 3, and this is equal to x to the negative 1, which we will see how to make this positive when we review the negative exponent rule. Power of a power, x to the a raised to the b, is equal to x to the a times b, or this can be just written as x to the ab. X squared raised to the 3rd power, this is x to the 2 times 3, which becomes x to the 6th. A negative exponent, to make the exponent positive, we have to put this in the denominator. So we can always write this as x to the negative a over 1. And so how we make this positive is just by moving this to the denominator. So this will be x to the positive 1 over x to the positive a. So for example, looking at this expression, x to the negative 1, so x to the negative 1, this is also x to the negative 1 over 1, and how we make this positive is just by moving this whole term into the denominator. So this becomes 1 to the x to the 1, and x to the 1 we can always just write as x, so this becomes 1 over x. Power of a product. So when the variables are different, when you have two separate variables, x, y to the a, you distribute the a to each of the exponents of the variables. So when you have just x and y here, the exponents really are just 1. So this becomes x to the 1 times a using the power of a power rule, x to the 1 times a, so this is equal to x to the a, y to the a. Power of a quotient, similar to power of a product, this becomes x to the a over y to the a. Looking at two examples of power of a product and power of a quotient, so x to the x squared and y cubed to the fourth power, this is equal to x squared times 4, y to the 3 times 4, so this becomes x to the 2 times 4 is 8, and y to the 3 times 4 is 12. Power of a quotient, if we have x squared over y cubed to the fourth power, this again becomes x to the 2 times 4 and y to the 3 times 4. So x to the 8th over y to the 12th. All right, so these are our exponent rules, and knowing these rules help us simplify and reduce expressions with exponents. And so, looking at a few examples, we're asked to simplify the following expressions with positive exponents. So usually when we're asked to simplify expressions with exponents, that means that we want the variable to only show up once. So if we have two x's in the expression, which in this case we do, we have the x to the fourth and x cubed, we want to only see one x in the final simplified version. Also, we always want to see positive exponents. So, we also treat constants as their own terms as well. So we have 2 and 5 here, so these are the constants. So the first step is to always identify where you can apply the rules. And then we have x to the fourth and x to the third, and y, and y to the negative 2. So let's start applying some of these rules. So we're multiplying, so this becomes 2 times 5 times x to the fourth times x cubed times y times y to the negative 2. So this step is really just rewriting it so the variables are, similar variables are next to each other. So we have the x's next to each other and the y's next to each other, and also the constants next to each other. So 2 times 5 is 10. And remember, applying this rule, the product rule, x to the a times x to the b equals x to the a plus b. So this becomes x to the 4 plus 3. And same for y, we're using the product rule. Y to the, this is technically 1, so 1 plus negative 2. So then this becomes 10 times x to the 7 times y to the negative 1. And we still want to make all the exponents positive, so we have one less step to take. So we can set this whole expression over 1, and how we make this positive is by taking this term and moving it in the denominator. So then we have equals 10 x to the 7 power. We actually use a different color here. X to the 7th power, and this becomes y to the 1. Or y to the 1 can just be written as y, so this is 10 times x to the 7th power over y. So this is the final simplified version. So we can say that 2x to the 4th y times 5 to the x cubed y to the negative 2 equals 10 times x to the 7th over y. All right, so for this expression, let's identify the x terms, y terms, and the constant terms. So we have the constants here. We have the x's here. And then we have the y's here. And using the quotient rule, so first we always divide the constants or multiply the constants, rather perform the assigned operation that's happening for the constants. So 9 over 27, this reduces to 1/3, 1 over 3, and then this becomes x. And when we're doing the subtraction of the exponents, we automatically put the variable in the numerator. So this is x to the 3 minus 12. And then we have y to the negative 10 minus 8. So this is equal to 1 times x to the 3 minus 12. 3 minus 12 is negative 9. And y to the negative 10 minus 8 is negative 18. And this is all over 3. So to make these exponents positive, we have to move both terms to the denominator. So this will become 1 over 3 times x to the 9th, y to the 18th. All the exponents are positive, and we're only left with one of the variables x and one of the variables y. So we're done. So we could say that 9 times x cubed times y to the negative 10 over 27 times x to the 12th times y to the 8th equals 1 over 3 times x to the 9th times y to the 18th. All right, and I will continue with this last example in part 2.